Oh, thank you very much. We're pretty much at the end of the day, so hopefully it will reassure you to know there are no equations in this presentation. I love them, but at this time of day I'm ready for something a little lighter, so hopefully it will work for yourselves too. This talk is partly founded on some of my PhD research. I have a 25-year IT industry career. I started out in knowledge management, collaboration, messaging, communication, moved more into data science over the last decade, and I actually took a full career break to go and study a PhD full-time. My interest was with this rise in use of mobile devices, the Internet of Things, the smart city narrative, was could we use data science to better understand people-place experiences, from pedestrian movements to understanding ambience of the environment, to potentially learning how behaviour changes to changes in environmental conditions. And part of that research went delving into could we sense emotion, and that is the foundation for this talk. And the short answer would probably be we really shouldn't. This came up literally a couple of weeks ago. Intel calls its AI that detects student emotions a teaching tool. Others call it morally reprehensible. And that's a painful title because there's been a lot of controversy over the last few years around sentiment analysis and emotion detection. And we're going to touch a little bit on why that might be. But this was part of the comment that was made, and I've highlighted a bit at the top. They were claiming the system can detect whether students are bored, distracted, or confused by assessing their facial expressions and how they're interacting with their materials while they're in front of their monitor on a Zoom call. Just let that settle for a moment. You know, it's just, seriously? I mean, most of the articles start with seriously, because, you know, what even defines a distraction? But this is by far not the first. This is just last week. Last year, Canon had this great idea that to use cameras and only let you into a meeting room if you're smiling, because meetings go so much better when we're all smiling. So if you can't smile, no meeting for you. There's actually an opportunity there if you want to reduce the number of meetings that you attend. Still not the first. This one, we're going back now. We're heading back about 4 years. It's well known that most call centres monitor our voices for tone and emotion and then adjust the scripts based on what they believe they're sensing our experiences to be. But think about it. You know, we can, on one hand, that kind of makes sense. I think, yeah, I can hear it in my voice when I'm a little bit nervous or a bit tense or a bit anxious. But is my level of anxious the same as your level of anxious? Probably not. And so would the response work the same way? Maybe, maybe not. You know, there's lots of questions here. And we can go back further. And then sadly, Facebook always has to take the ultimate blame, because there's been a couple of big stories that came out of Facebook using people's news feeds to try and not only detect emotion. There was another study, which I haven't put up, which tried to nudge emotion, which was absolutely appalling that anyone even thought it was a good idea to try. And the argument being that it was harmless. It was tiny micro percentage points. And it's like, well, did anybody consult a psychologist? Because it's well known that we tend to have tipping points. You know, it might be that it was a minor little thing in the newsfeed, but if you've just had a day, a week, a month of something terrible, one tiny, seemingly inconsequential detail can be just what it takes to tip you over the edge. Absolutely, that nobody thought of that was quite shocking. But why do we want to even do this? What's the fascination with emotion? And there's lots of different quotes I could pull out, but this one's quite a nice old one, 1975. Logic rarely solves disputes but when there is mutual understanding of feelings, it is far easier to reach a solution. This means instead of trying to win using logic, try instead to understand by listening to feelings, yours and theirs. This belief that if we connect through emotion, we'll get to a solution far faster than if we try and use cold, hard, rational logic. And obviously the logical conclusion, using logical, totally inappropriate there, is it moves to manipulation. Because if we realize this works, we can start to manipulate people. And there's a whole realm of research in marketing that's been doing exactly that, and we're seeing a lot of it today on the internet. But we're not going to delve all into that. That's a whole other talk, and we'll do that next year perhaps. Where does this whole desire to do AI and motion detection come from? And it really grounds in this concept of affective computing, which was defined as computing that relates to, arises from, or influences emotion. And it was actually defined by Rosalind Picard, a computer scientist, in 1995. And she came up with this sort of system of levels to determine how close were we getting to a computer being able to exhibit affective computing, from the absolute can neither express affect, can't recognize it, mindless. It's just a grey box, no emotion going on there at all. In reality, probably the early stage focus was making computers seem like they had emotion, but they couldn't recognize it. At my age, and I'm older than quite a lot of you in the room, probably the first sort of machine with emotion for me was R2-D2, sort of wobbling about in Star Wars, sort of showing excitement through his motion. WALL-E, for those of you that know the Pixar movement, I remember a great explanation from the animators saying they wanted to try and figure out how he had elbows, because if they had actual elbows, it didn't really work with the animation, so they moved his shoulders and had this movement, but it doesn't understand it, but can express affect. But what we've seen more recently, and what we saw with that Intel and the Canon case study, is increasingly using machines to evaluate our emotions, so recognizing affecting us. So that level 3 can't respond to it, can't do anything with it directly back at us, but recognizes as and potentially changes a script for somebody else. And then the 4th level, where it goes two-way, where literally the computer responds back to us as well and also expresses affect in a way that we resonate with. And it's argued we're not really there yet with that one. So how have we been doing? Why has this all changed? And this is the funniest thing. I mean, are most of you familiar with XKCD cartoons? They're great fun cartoons, but sometimes they get it wrong. So this one was, when a user takes a photo, the app should check whether they're in a national park. Yeah, easy, done. GIS software, give me a few hours. And check whether the photo is of a bird. Oh, I'll need a research team and 5 years to figure that out. And the argument was being because we still hadn't got to the point with computer vision that it could cope with high-resolution images and detect all the objects in. This was published on the 24th of September 2014. And then in 2015, Microsoft Research announced the first computer vision algorithm to beat humans at the annual ImageNet competition. For the first time, the error rate of the computers was lower than the humans at classifying birds, amongst other things, in high-resolution images. 6 months. And it's not the first time we've had a claim made that something's never going to happen, or it's impossible, or it's a long way out, and then the very next day, we get a major breakthrough and everything changes. And it's carried on into language as well. Since the papers and the research published on transformer models, and we've seen some of that earlier today, we've seen ever bigger models being developed with ever more parameters. So to the point that this one was announced last year from Microsoft and NVIDIA, and I have to read it because I haven't memorized this yet, but they literally claimed it's got unmatched accuracy in a broad set of natural language tasks, including reading comprehension and common sense reasoning. So it sounds like we're getting really, really close to the machines being so like us with language. And in the same year, Delphi was launched, a research project that was about asking questions and getting moral answers from the AI. And it was interesting because I actually pushed back against the transformer-based model, saying you don't need all those big models. Actually, we've done it on a much smaller set, and we've got 92% accuracy, that the AI, given a moral dilemma, comes up with a good answer. And naturally, Twitter had an absolute field day at testing just how accurate 92% is, what questions were used in the training set. And this picture up here, there's using an algorithm to make a moral judgment about a situation. Asked Delphi, I asked it. To be precise, it's wrong. It's like, well, at least it knows what it's doing is wrong. This is a start. So there's been lots and lots of developments. But are we still any closer to getting to the point they can reliably detect emotion? And I would say there are 3 key challenges: data, theory, and culture. And I'm just going to give a couple of examples of each quite quickly. First up with the data, because we've talked a lot about the algorithms today, and we've talked about using different data sets and how we can extract valuable information out of them. But we do need to start asking about the data itself. And I think at least a couple of times, and I haven't sat through all the sessions, apologies, but I heard the question asked at least once, but what if the data's wrong, that we're building these models off? And it's a really, really good question. Is the training data representative? And so this was literally published yesterday, nothing like a nice up-to-date paper going online. The Open Pre-trained Transformer Language Models by Meta And it's actually fantastic. They've created a completely open one that we can all inspect, as opposed to the oddly titled OpenAI GPT models, where you have to apply to get access, and the latest version is actually quite hard to access entirely unless you're in a very small select circle. But what's interesting, they've also published very specifically the data that the model's been built from, and it includes this general set, one of which, and I've highlighted it, is pushshift.io Reddit. And by Reddit, yes, that Reddit. We have to think, when we talk about, we're collecting data off the internet to train these models, well, who creates that data? So, who does? I looked it up. The demographics of Reddit, who uses the site? Over 50% of users are registered in the US. So it's predominantly a US site. It accounts for over 50% of the users. They're pretty sure over 2/3 of the users are skewed towards male identity, and it's believed it's more likely over 80%, but nobody has to actually tick a gender box, so it's based on names and usernames, for example. Only 7% of users are over the age of 50, and the most popular, the biggest subreddits, announcements, funny, ask Reddit. This is the data that we're building our models on. Is this data representative of everybody's views in the world? No, is the short answer. And so it's a concern. Let's keep going a bit further, because Reddit's not the only source that's quite popular for research. There's been a lot in the news. This came up in 2020, and it's been back in the news in the last few days. This idea that maybe a lot of our thinking of history is quite wrong, and that we've been making assumptions about roles that aren't true. And so we have to always ask, well, who writes the history? And then who writes up and summarises the history on Wikipedia? Approximately 90% of editors on Wikipedia are believed to be male. Approximately 80% of all biographies documented on Wikipedia are about men. And the challenge, and this is a quote from a person that's trying to redress that balance, is there's just been so much written about men and not so much about women. And yes, that's true. Because if you were an opinionated woman 200 to 300 years ago, there was a stake with your name on it while you were still alive. It's just, that's our history. We can't deny it. It is our history. We're aware of it, and that's fantastic. And that's actually the power of data science, because we've got the opportunity now to understand and collect this data and challenge it and be more selective about, well, what do we want to represent our future? Because do we just want it to repeat the past? These are key questions we should ask. On to theory, because we can beat data up all day. We can have a field down all the different biases, but data's not the only part of the algorithm. There's theory. Why have we built this algorithm? And when it comes to emotion detection, a lot of the computer vision algorithms initially were based around Ekman's model for emotion detection, which was all about the very specific placements of the muscles in your face could be categorized to different emotions. And this is a quote direct from one of the papers. Joy, anger, fear, and sadness contain one or more muscular actions that most people cannot perform deliberately. Apart from actors, it seems, because he then recruited actors to perform these expressions, to document them, to prove the fact that other people couldn't actually, fake them. Little bit odd. But it gets better. What emotion is this? Using his 4 main categories, anger, fear, joy, sadness. If somebody came up to you, came up really, really close with that expression, would you be happy? Now what do you think? Possibly quite differently, but not certain. It kind of looks like it's possibly elation, a hard-fought 1 point. Yes, got it. And that the colleagues coming up to high-five him, well done. But we don't know. If we rolled the video, it could actually be the referees just disallowed the point. And he's thinking, I'd like to do to that ref. And the guy's going to calm down. There's another 10 minutes to play with the game's not lost yet. We don't know. We haven't got the context. We don't know. How can we expect a machine to know? And this is a big challenge with emotion detection. It's the one thing that I really have I've done variations. I update and change it each year, but I'm going to keep doing this talk until I get some movement on stopping trying to detect emotion in students at school. There is still no consensus on a definition of emotion, and theorists and researchers use emotion in ways that reflect very different meanings and very different functions. It's generally accepted there are certain core emotions across many species. You can see fear or anger in other animals too. The challenge is it a distinct set of expressions that only means anger? That's the challenge. Is it discrete that we can say that definitely means it, that definitely does not? This is where it gets really messy. And it's really an acknowledgement, and it's the image on the right, which I took part from me summarising my research, is there's so much we still don't understand about the human mind, or even the brain for that matter. There's a lot of things that are not yet solved problems, and we're in danger, particularly with computer science, to be leaping ahead, because now we've got the power of the compute and we've got the data that we can just leap ahead and start to jump into this space when it's very, very ill-defined. There's been a lot of work on cognition, not so much on affect, and even less on conation. We understand to some extent that temperament comes from our genes, from our phenotypes. There's a lot of complexity there. So we are making great leaps and strides here, but it's not a solved problem, and yet we're building commercial solutions on it. And this is, to just point this out, Lisa Feldman Barrett, really, really good book for anyone interested in the issues with emotion detection, on how emotions are made, published in 2017. She challenged a lot of Ekman's research. And this is just one example, and I must explain, the photo is not from the book. I just picked one that was on Wikicommons that could be used publicly. Because it proved that with a lot of the research that had built this category, this classification of facial movements, was based on priming. People were generally given a photo in either a category card with a list of emotions to pick from, or they were given a scenario. He just witnessed a shooting on his quiet, tree-shaded block in Brooklyn. And what they found out when they tried reproducibility on this, it turned out 66% of people will rate the emotion as fear with and without the photo. They don't even need to see the face. They've already made the mind up. If you're in that scenario, I think I'd be fearful, so tick, fear. Don't need a photo at all. Take away all context, and the same image became 38% rated the photo as fear, 56% rated it as surprise. It's a big leap from fear to surprise. That means a very, very different context. The fact is we're not very good at it. We're not very good at detecting emotion in humans. How many of you in the room, it's happened to me because I do not have a good resting face. I actively smile as much as I can when I'm in public environments, because when I'm resting, it doesn't look great. And it's that, it's cheer up. It's like, which I could have a psychology session here. Why do you think, if you genuinely think I'm not happy, why do you think saying cheer up is going to improve my mood whatsoever? Not happening. But usually it's like, oh, sorry, I was just thinking about something. It wasn't sad, I was just thinking. It's okay. So this is it. We're not good at it. And then finally there's culture, and I swiped this one off Twitter from March. I need people to understand not all cultures communicate the same way. In my culture, it's very normal for people to talk over, interrupt each other, and it is not automatically considered rude. Stop attributing personality flaws to people because they don't share your cultural norms. This is a huge, huge issue with real-world evidence, real-world data. It's across a broad population with lots and lots of different approaches and focuses and different ways of communicating. And so when we say natural language processing, it was correctly explained. We're talking about the spoken language, but which spoken language do we often focus on? It's overwhelmingly Western. On the whole, Western English. And so this paper from 2019, African Americans are up to 2 times more likely to be labelled as offensive compared to others. Why? Because the dictionaries, and they were dictionaries in that case that were being used, do not represent the way they speak. They represent a different culture. And it's the same with labelling. If we label speech, who's doing the labelling? What are their cultural norms? How might that affect the labels that they choose? And I use this spoof on the right-hand side, what the British say. As you made sense from the accent, I live in Zurich now, but I am indeed British. What they mean and what is understood. And, that's not bad. It's quite a common phrase. And we're generally being complimentary, but it's not always read that way. We think that's really good. Others think, they just think that's poor. And then there's the dreaded quite good, because there's quite good. It's not good, really. And then there's quite good, which means it's bloody fantastic. Pardon the French. And this is it. So it's really hard to pull out that nuance and build that into an algorithm. And it's really important because culture influences theory. And I'm going to switch over into medicine a little bit here, because heart disease, it was in the news a lot last year, actually over the last 2 years. In the 1700s, heart disease was associated with emotional excess, anger, which meant only men could possibly get it. Because back to the earlier example, if a woman expressed it, there was a stake with a name on it. Literally. We were not allowed to be angry in that era. Certainly not in the UK, but in quite a few other places in the world. Sadly, some still true today. By the 1800s, Enlightenment age, now it's no longer about anger, it's about stress. But it's still male stress. So this is taken from Dr. William Osler, who was an earlier expert on this, and it's not my field, so I am literally just quoting verbatim. The typical heart patient is a keen, ambitious man, well set. He's done well in his life and eaten well, from 45 to 55 years of age. And that became the framing for who is likely to have heart disease. By the 1900s, more enlightenment, more science, more research, and now heart disease is associated with diet and exercise. So we're getting there. But not quite. Because when we have theories, they influence the data we choose to collect and the types of research we conduct. And the two major studies that influenced some of the guidance around heart attacks over the last 20 years, participants for each slightly skewed. For the first 1982 study, all men, 0 women, all middle-aged. Second study, all men, 0 women, all middle-aged. And this is not just a gender issue, because young people can have heart attacks too, and their symptoms are very, very different. But this is the power now of data science, because we're becoming aware of this, and we now have the ability to be much more open-eyed about, we might have been conducting trials that are not being representative of the application. And so we can do something about this now. So this is actually a good thing, but we need to be aware when we're using archived data, that data's probably got a skew to it. So can an AI detect emotion? Now, the real question is, can humans? That's the reality of it. Because if there's so many areas around the data, our culture, our theories, these all create challenges for us that mean we have different views on emotion. And so whose view then gets baked into the AI? That's a big question. So to near close out, and just a slightly duller slide, I use emotion, but actually I consider these to be broader challenges and opportunities for data science as a field. I think it's important when we're using real-world data to appreciate it's not some benign object. They're often behavioural traces. There are people behind those data points. Do we ever think about who they are? Human judgments, heavily influenced by context and culture. I hope nobody would disagree with that. But we then write our history from that influence. And then we use that history to build the next models. Algorithms are susceptible to flawed data, and I think everybody would be aware of that, but we don't talk anywhere near as much that they are also susceptible to flawed theories, because theories are also embedded in culture. And take the field of psychology, you can go through the industrial age development for the terms that get used, blowing off your steam, because in that era of psychology, we had the steam engine. Compared to now, the brain is always compared to a computer, because we're in the compute age. So culture very much influences our theories too. Predictions create consequences, and so we need to be very aware if our models might have these flaws in them. We need, and it was great because this has been covered in earlier sessions, we need much better methods for aborting causality or lack of evidence of, and uncertainty as well in our models. I don't think we're anywhere near good enough yet, particularly where we're in the more subjective spaces. The key for this, though, for me as well, is we're seeing an increased demand around citizen data science tools, low-code, no-code solutions, and commercial applications, and they rarely reveal any weaknesses in the underlying models or the assumptions they've been built on. So I think we have a responsibility to bring that rigor into the models, because otherwise we don't know what the consequences are going to be. And then that final point is that really machine learning operations to me needs to become as important as the development of the next generation of algorithms to provide that end-to-end observability, accountability, responsibility for what we're doing with these models, why we're building them, how are they going to be used. And so just to close out, this has not been a talk about Databricks, but I do work for Databricks. And I just wanted to explain, because I stepped back from academia into industry, because this is something that interests me. As much as I get excited about the next algorithm, I want those algorithms to be accountable. I want to improve our ability not only to build these models, but to monitor them, to pick up the drift when the data changes, to be able to turn the AI on itself and tell us more about the data that we're using. Tell us the spread on Wikipedia, the coverage. Do we think it's representative? And so it's just a simple closeout. As I've got 30 seconds, is we're hiring too. I've got to say it because my boss told me I could include this day happily as long as I said we're hiring all roles. So do come and talk to me. Patrice is one of the organisers here too. Do come and have a chat. But with that, I'd just like to say thank you.